Hello everyone, welcome to the series of data analysis using JAMOVI. This is Dr. Atman Shah. In this video, I am going to discuss how to perform ANCOVA, that is analysis of covariance in JAMOVI and its interpretation. You can find more videos on data analysis using JAMOVI, SPSS, RStudio, MS Excel, econometrics and statistics on my YouTube channel. So don't forget to subscribe and press the bell icon. So let's begin with the idea of ANCOVA. ANCOVA is used to analyze the difference between group means after controlling the effect of the covariate. Now covariate is the continuous variable which can have the effect on our dependent variable. Now let's understand this with the help of example. Suppose here we have three variables. You can see one is teaching method, that is nominal variable with three categories: teaching method 1, 2 and 3. Result of the students out of 50, that is our continuous variable, and library hours per day, that is also a continuous variable. So here we are interested to know the effect of teaching method on result of the students by controlling the effect of library hours. So this controlling variable is known as covariate. So after controlling the effect of library hours on result, we want to check whether we have the significant effect of teaching method on result of the students. That means the mean of result among three teaching methods is significantly different or not. So let's understand this. Now what is null hypothesis in this case? Null hypothesis says that there is no significant effect. Null hypothesis H naught, no significant effect of teaching method on result after controlling the effect of library hours. That is our H naught. And what is H1? That is alternative hypothesis. We have the significant difference. So if you find the significant difference, we need to perform the post-hoc analysis. Now let's understand how to perform it. So first you go to analysis. In analysis we have the option of ANOVA, and in ANOVA we have ANCOVA. Analysis, ANOVA, ANCOVA. So you click on it. The dialog box will appear on your screen. So now in this case, what is our dependent variable? It is result. So move result to dependent variable box. Our fixed factors is method, in which we have three categories. And what is our covariate? Our covariate is library hours. That means we are measuring the effect of teaching method on result after controlling the effect of library hours. So here we have the result, and then you select partial eta square. Select partial eta square. Also select overall model test. Now let's understand, or let's interpret the result. So first we have the overall model. See here, this is our overall model. The F value is 34.6 and associated P value is less than 0.05. Therefore entire model is statistically significant. Then we have the effect of method. It is also statistically significant. That means the mean of three different teaching methods, the mean of results for three different teaching method is different. Now which group is different, that we do not know. For that we need to perform the post-hoc analysis, but at least one group is different. So therefore we have statistically significant result. Then we have library hours. It is also statistically significant. Now this partial eta square shows the variance or variation in result due to teaching method. So see this, it is 0.611. That is 61.1% variation in result can be explained through teaching method. That is the idea of partial eta square. Okay. Now we are going to see the interaction effect. So you click on model, select method and library both and move them to model. Click on this right arrow, select interaction, and in model terms you can see method cross library, and that will give you the interaction effect, that is here. We can see that interaction effect is not statistically significant, whereas individual effect, that is method, is statistically significant. Now let's see the assumptions. So here we have assumption checks. So we can see the homogeneity test, whether variances of three different groups are homogeneous or not. So you can see the p-value are greater than 0.05, and therefore we fail to reject the null hypothesis of equal variances or homogeneous variances. So we can say that as per Levin's and Bartlett's test, the variances are homogeneous. Then we can check normality assumption. So click on normality test. So we have the result of normality test here. Again you can see all p-values are greater than 0.05. So we fail to reject the null hypothesis of normally distributed data, and therefore we conclude that our variable or our data is normally distributed. Now we want to test that which teaching method or which group is different from others. For that you go to Post-Hoc, move method to the right box. By default Tucky is selected, so you don't need to change anything. Simply check the result of the Post-Hoc analysis, and this will give us the idea that which group is different from others. So here you can see method 1 and method 2. This is mean difference. Associated p-value is less than 0.05. That means teaching method 1 is significantly different from teaching method 2 in terms of mean result, or we can write mu1 is significantly different from mu2. Now you check mu1 and mu3, that is teaching method 1, teaching method 1 and teaching method 3. So this is mean difference 11.48. Associated p-value is again less than 0.05, and therefore mu1 is significantly different from mu3. Now you see the difference between method 2 and method 3. Mean difference is only 1.98, and it is not statistically significant as the p-value is greater than 0.05. So mu2 is equal to mu3. So we can write that mu1 is significantly different from mu2 is equal to mu3. That is, mu1 is different from mu2 and mu3, but mu2 and mu3 are not significantly different from each other. That means teaching method 1 is significantly different from 2 and 3 as far as result of the students are concerned. And now we can actually visualize this. So you go to estimated marginal means, select method and move it to this marginal means dialog box, and then you see the result. And you can also select marginal means table here. So here we have the mean. See this, that mu1 is significantly different from mu2 and mu3, but there is no significant difference between mu2 and mu3. And here we have the visualization of the chart. So that is the idea of analysis of covariance. If you find this video useful, kindly like, share, comment and subscribe. Thank you.